Good afternoon. So, Regents, we are about to take a giant pivot away from mechanics, which we have been studying the entire year so far. We're about to pivot towards the three other topics that we have to hit before the Regents exam. The first of those is electricity. And in order to start talking about electricity, we first need to know why electricity as a phenomenon happens in the first place, and it happens because of electric charge. Now, almost everything that we have done up to this point in the year has depended on an object's mass, okay? With the exception of kinematics, almost everything we have done, we have had to know what the object's mass is. Sorry, let me just reorient this. There we go. Almost everything we've done, we've had to know the object's mass, with the exception of kinematics. Force required us to know the mass. Circular motion, gravitation, momentum, and energy, all of those at some point required us to know the mass of the object, how much matter was in the object. However, when we talk about electromagnetism, it is not so much the mass that matters, it is the electric charge. Not saying the mass doesn't matter, but electric effects happen because of an object that has what's called electric charge. So, what is electric charge? Electric charge, that's almost as hard to define as mass was. Mass is how much matter something has, but even that's a very vague definition. Electric charge is kind of the same thing. Here's the book definition of electric charge. A property of matter that determines how much an object is affected by electromagnetic forces. More charge equals a bigger effect. Okay, a property of matter that determines how much an object is affected by electromagnetic forces. It almost seems circular, okay? Electric charge tells you how much electricity affects it. So what is charge in the first place? And I have to kind of stop there, because if you're looking for, why do objects have charge or what is charge, that is the best we can do. Charge is something that certain pieces of matter have that allow them to be influenced by electromagnetic forces. We don't have a better definition than that, okay? Electric charge is just something that objects have, okay? And it causes them to be affected by electromagnetic forces. The more charge they have, the bigger the effect. Now, you do know some things about charge. And this is it's not going to seem exactly like a review of chemistry, but a lot of the stuff that we're going to talk about is stuff that you talked about in chemistry last year. And I'm not saying, this is not really intense chemistry stuff. I'm talking about the basics, okay? Last year in chemistry, you talked about charges on certain particles. And we'll get to those in a second. But you know that objects can have certain charges. They can have a positive charge. They can have a negative charge, or they can be neutral. And we'll get to those particles and what they are in just a second. So, why do objects have positive, negative, or neutral charges? It depends on what they're made up of. It is because they're made up of different numbers of the positive charges ultimately come from protons. The negative charges ultimately come from electrons. And objects that are neutrally charged, well, we have a particle that it has a neutral charge. We call it a neutron. Okay? So, protons and electrons are the important ones because those are the ones that have charges. Not to say neutrons aren't important, but protons and electrons have charges. Protons are positive, P and P. Electrons are negative. Okay? Neutrons are the neutral ones. So, last year, you talked a lot about models of the atom. So I'm going to draw an atom for you right now. We're going to have a little key over here. And again, this is really basic chemistry. Even if you didn't do good in chemistry, you're going to remember this stuff, okay? Let's use a colored in dot like this as a proton. Make that a little bit bigger. a blank one as a neutron, and then a little tiny blank one as an electron. So last year you learned the location of these different types of particles. You remember that protons and neutrons, the positive and neutral charges, are found inside what is called the nucleus, the center of the atom, and the electrons are in orbits around it or in locations around it. Okay, so I might have something like this where I have, I'm just going to do, let's say, 6 of each. You guys can watch me color for a little bit. Woo, how fun. Okay, so let's say that that is essentially a nucleus. You've got 6 protons and 6 neutrons together, and then around the outside are the electrons. This is a terrible drawing, but we're just going to go with it. This is your basic picture from last year, okay? Now, obviously, it's a little different than this in reality, but this is a generally good enough model. So again, we have electrons in the orbits around the outside. We have protons and neutrons in the nucleus. You typically do not find electrons in the nucleus or protons and neutrons outside the nucleus except under extraordinary circumstances. Okay, by the way, I think, oh, hold on, let's see, this, is it carbon? Yeah, okay, I think this is an atom of carbon. Someone double check me with that on the reference tables. I could be totally wrong and embarrassing myself right now, but I think off the top of my head this is carbon that I've drawn. I would get out your reference table, your physics reference tables right now just to have them handy, because some of the stuff that I'm about to talk about is going to be on the reference tables, and unfortunately I don't have a copy of the reference tables at home with me. So I would take out your reference table so you can kind of double check and see where all this information is located. Again, we're going to be on the front page this time for this unit, and I think there's an electricity page maybe 3 or 4 pages back. It says electricity and magnetism on it or something similar, okay? So we got to talk about differences between protons and electrons. First difference, in mass, and this is right on the reference tables, on the front of the reference tables, I believe. Protons have a mass of 1.67 times 10 to the negative 27th kilograms. 10 to the negative 27th, that is tiny, absolutely tiny. Electrons, on the other hand, have a mass of 9.11 times 10 to the negative 31st kilograms. Okay? Which one is smaller? Definitely the electron, okay? 10 to the negative 31st means you have like 3 or 4 more extra zeros before you get to this number with an electron than you do with a proton. So protons are more massive, okay? Protons are the ones that have mass. How much more massive? Well, we can find that out by, let's see, 1.67 1.67 EE negative 27 divided by 9.11 EE negative 31. Protons are approximately 1,800 times more massive. So compared to the electron, the proton basically has no mass. It would be like comparing my mass to maybe, let's say, the mass of, let's see, what am I, like 160 pounds? We're looking for something that's like 1/10 of a pound, okay? We're talking about a huge, huge difference in mass. We basically say that electrons have no mass because they're so small mass, such a small mass in comparison to the proton. Next difference. Protons are typically found, and this is what we talked about earlier, in the nucleus, in the center of the atom, whereas electrons are typically found outside the nucleus. Okay? Electrons are outside the nucleus, protons are inside the nucleus. Typically, you will find that electrons have an ability to leave their parent atom completely and move around. They can jump between atoms. This is what happens when objects bond. Or when an electron just up and leaves its parent atom, we call that, if you remember, ionization. Protons, on the other hand, under normal circumstances do not. Protons are stuck in the nucleus. We very rarely see them outside the nucleus. It is possible to see an isolated proton or an isolated neutron, but what I'm saying is if you have a proton that's already in the nucleus, it's typically not going to come out of that nucleus, okay? And the big difference, protons are positive and electrons are negative. Now, I've been neglecting a neutron. A neutron is very, very, very similar to a proton. Matter of fact, I believe that the mass of a neutron is on the reference table, and you'll see that the mass is almost exactly the same, or it is the same. A neutron is basically just a proton with no charge, for your purposes. Okay, protons and neutrons have approximately the same mass. The only difference is that a proton is positive. It has an electric charge, while a neutron is neutral. Okay. One thing that protons and neutrons do have in common, or protons and electrons, excuse me, even though one is much bigger, the other one is much smaller, one is found in the nucleus, one is found outside the nucleus, one is positive, one is negative. This is the key similarity between the two of them. Protons and electrons have the same magnitude or amount of charge. Okay? They have the same magnitude of charge. Now, what this means, if we want to talk about charges, you did this a little bit last year. Okay? Last year, you talked about protons and electrons. You said that protons have a charge of +1 and electrons have a charge of -1. What you were really doing was giving the charges in units of what we call the elementary charge. You might remember last year talking about if an object gained an electron, it became negative, okay? GENLEP, lose electron, positive, gain electron, negative. When it gained an electron became negative, you would say that that overall atom now has a charge of -1. What you were talking about was that the overall atom now has a charge, an overall charge of -1 elementary charge. And the symbol for elementary charge, I don't think you used it last year, maybe you did, is a lowercase e, okay? And you remember this from chemistry. If, on the other hand, an object lost an electron, hopefully I said gain before, if an object lost an electron, it became positive because now it has one more proton than electron. And you would refer to it as having a charge of +1. It's really +1e, +1 elementary charge, okay? And again, this is from chemistry. If an atom gained 2 electrons, it would have a charge. If it gained 2 electrons, gain electron negative, then it would have a charge of -2, okay? So, in chemistry, you deal with one charge at a time, 1 or 2 or 3, very small numbers of charge. In physics, we deal with large groups of charge that are much bigger than just 1 electron or 1 proton, okay? The unit of electric charge in physics is known as the coulomb, C-O-U-L-O-M-B, and that has a capital C on it, okay? And the symbol is capital C. Now, in your reference tables, there is a conversion between elementary charges and coulombs. And your reference table tells you that one elementary charge, one single electron or proton, that size charge is equal to 1.6 times 10 to the -19th coulombs. One electron has this much charge if measured in coulombs. Now, that is a tiny, tiny number, okay? So, we also might want to know how many elementary charges does it take to make 1 coulomb? And thankfully, that is also written on your reference tables, okay? That number is 1 coulomb is 6.25 times 10 to the 18th elementary charges, okay? So, how do we get this number? Okay, and how do we know this number in the first place? I'm not going to go into why this is the number just yet. But if you know that one elementary charge is equal to 1.6 times 10 to the 19th coulombs, the way you can get to this, these two, if you take these numbers, one thing that you'll notice, if I were to multiply 1.6 times 10 to the negative 19th times 6.25 times 10 to the 18th, look at that, I get 1. These two numbers are inverses of each other. In other words, if you take 1 coulomb and divide that by the 1.6 times 10 to the negative 19th coulombs per elementary charge, you end up with this number. Okay, that's where this number comes from. You really only need to know one of these conversions, okay, but both of them are listed for you, all right? This is going to get into some unit conversion, like stuff we did from the very beginning of class, okay? You're going to need to remember how to do unit conversion. So, a couple quick little notes. -1 coulombs of electrons. If you had a coulomb of electrons, that would be -1 C. What that means is you have 6.25 times 10 to the 18th electrons. If you had a positive coulomb of protons, well, that would mean you have 6.25 times 10 to the 18th protons. And again, 10 to the 18th, think about that number. That is a huge number, okay? That's 6.25 followed by somewhere in the teens number of zeros. That's a huge, huge number. If this is